So I'd like to present the biomedical physics curriculum within this master degree in physical sciences. Let's start with what is biomedical physics. Basically, it's a multidisciplinary field that applies principles and techniques of physics to the study of medicine, biological system, and phenomena. This field required the integration between knowledges from physics, but also biology, medicine, chemistry, to advance medical science and healthcare. So our biomedical physics program focuses on the use of basic and applied research. The key aspects include medical diagnostics, clinical therapy, and health protection. In particular, within the medical diagnostics field, we study the imaging techniques. So we study magnetic resonance imaging, computed tomography, positron emission tomography, and also ultrasound. But we also study the development of a sensor in order for monitoring some vital signs and therapy by measuring some suitable biomarkers. In the clinical therapy, we study cancer therapy, both conventional but also new radiotherapy techniques. We can think about hadron therapy, for example, so the use of protons, carbon ions, in order to increase the effectiveness of the tumor treatment, or boron neutron capture therapy, or magnetic fluid hyperthermia. In the health protection, we study dosimetry, but also radiation protection, and also radiation biology. So what we are expected to learn during our biomedical physics curriculum, basically when you will finish your study, you will have a knowledge about physical and biological processes, in particular regarding biomarkers, but also radiobiology, which is the branch of biologists that study the interaction of radiation with the tissues and the living system. Then you will study some physical techniques. So you will learn about the interaction between the radiation and the matter, so nuclear physics, but also the solid state physics, which is very important, for example, when we want to advance in some imaging techniques, when we want to apply to the development of a biosensor or a drug delivery system. And then you will be familiar in the instrumentation. So basically, we will study diagnostic instruments, such as, for example, tomograph, or you will study detectors and dosimeters. And finally, you will study mathematical and computational methods. In particular, you will be able to simulate physical processes and also to use, for example, artificial intelligence tools in order to analyze biomedical images. So I want to show you an example of how the skills that you will acquire are very important in the research in oncology, that here in this department stands out thanks to the collaboration within many different centers, national and international centers, but also with some hospitals here in Pavia, the CNAU Foundation, the LENA Laboratory. For example, in the research in oncology is very important, the part of imaging. And as I told you before, we can apply different modalities of imaging, so MRI, CT, ultrasound, and so on. Then there is the part of image analysis and treatment planning. And in this case, the artificial intelligence can play an important role in order to enhance the performances. Then for sure, it's important to study different innovative radiation treatment when, for example, conventional treatment failed. And in this case, you need to evaluate which are the effects, both at a cellular but also a subcellular level. And this needs to be done experimentally, but also with some computational radiobiology and biophysics. And all of us, with my colleagues, all of us work in some of these aspects, also thanks to the collaboration with the National Institute for Nuclear Physics. So why we are a physicist is important in the biomedical field. Let's say that the medical, diagnostic, and therapeutic techniques are advancing very rapidly. And in medicine, we use radiation. So the physicists play an important role because it brings crucial technical and theoretical skills. And these skills will complement to the one of other scientists, let's say biologists, mathematicians, chemists, and so on. So before moving to the list of the course that this curriculum offers, I want to show you some of our research labs and our research activities. Because during your master degree, you will be dealing with this kind of laboratories in order to master the biomedical physics instrumentation. And we have the radiobiology laboratory, in which we study the effect of ionizing radiation and at a biological level. So let's say we study the DNA damage and repair, we study the immune system response. Then we have the ionizing radiation laboratory, in which you can learn how to use scintillation detectors, but also solid-state detectors, and all the instrumentation used in the biomedical physics. And then there is the NMR lab, so the nuclear magnetic resonance lab, in which you can explore, for example, the use of magnetic nanoparticles in order to increase the contrast in MRI images. Moving to the research activity, we can divide them in oncologic therapy, diagnostics, and radioprotection. In the oncologic therapy field, there is the group of Francesca Brero that work on simulation for hadron therapy. In particular, they work on the calculation of the effectiveness of hadron therapy, so the use of carbon ions, proton, helium ions in order to kill tumor cells. Then there is the group of Silva Bortolussi and Nicoletta Protti, in which they study the boron neutron capture therapy, which is this target radiotherapy that uses the capability of the boron-10 to capture neutrons. Then there is the group of Alessandro Lascialfari, in which we study magnetic fluid hyperthermia, which is this kind of anti-tumor techniques that uses magnetic nanoparticle that can release heat that weaken tumor cells if we apply an alternating magnetic field. Then there is Giorgio Baiocco group, and they apply the microdosimetry in particle therapy. And then some other colleagues study plasmonic nanostructure for photothermal therapy. And in this framework, I want to underline also that this department organizes every year the International Giant 4 School that is free for the master student, and is an event aimed to exploring the advancement of the Giant 4 toolkit in the field of medical physics. And here you can find all the information you may need. Moving to the diagnostic part, we work on magnetic resonance imaging. So there is all this research on new materials, software, but technologies in MRI for diagnostics and also therapeutic purposes. Then we have all the part of artificial intelligence in medicine, so the use of deep learning, machine learning, and radiomics in order to analyze the medical images to obtain, for example, to develop predictive models or to obtain some quantitative information of the disease progression. Then there is the group of Fontana, and in which they study the cross-section for the identification of new radioisotopes that can be used as a theranostic agents, so as a therapeutic and also diagnostic agents. And then there is the laboratory of Lena, in which they produced the fluorine-18, which is used for the positron emission tomography imaging. Finally, last but not least, there is the radioprotection field, in which they study basically the dose calculation in different situations, let's say in medicine, but also in the industry and in space, putting attention also to the role of shielding in reducing the radiation exposure. So now we can move to the study plan. This course, as Professor Gerace told you before, is completed in English, and you need to acquire 48 credits. So basically, each of these course is 6 credits. So you have to attend 8 of these courses and need to be divided in these different scientific sectors. So starting with ionizing radiation, we have physics of ionizing radiation, medical diagnostic techniques with ionizing radiation, introduction to ionizing radiation protection, and also a laboratory of ionizing radiation. Then we have particle physics, particle detector, quantum electrodynamics. Then for the non-ionizing radiation field, we have physics of medical imaging and also rheology and diagnostic techniques, which is both theory and practice course. Then in the field of artificial intelligence and simulation, we have artificial intelligence for experimental and applied physics, simulation in experimental and applied physics, in which you will be able to simulate the interaction between radiation and matter and how to model the processes in the living organs. And then there is computational methods in physics and statistical methods in physics. After these 48 credits, during the 2 years, you have to acquire also 12 credits between these 5 courses that are general biology, radiation biophysics and radiobiology, machine learning, MRI physics for neuroscience and bioinformatics. Then you have 12 credits that you can take from free choice courses, and finally 48 credits with your final thesis and other activities. Indeed, after getting the exam, you need to do your thesis, which can be done here in the department, but you can also do your thesis, for example, in some company. Here I listed the Stellar, the Bracco and Bruker companies, but you can also decide to go in some hospital, for example, the Policlinico San Matteo here in Pavia, the Knauf Foundation, or to the Lena laboratory. In general, there is an international network of research groups, also within collaboration for European projects. Then, as Professor Gerace told you, this master degree program take part to the LM Plus program. In particular, you can decide to spend 2 semesters in some internship at centers or companies. And tomorrow here at the physics department in this room, you will have a presentation meeting of companies and their project. And in particular, in the biomedical field, you will have the Bracco Imaging Company and the Knauf Foundation. Here for this kind of program, the coordinator is Professor Gallinetto. Then what you can do after getting your master degree, you have multiple choices. You can decide, for example, to stay in the research. So you can start to do your PhD here or abroad. Here we have a 3 years program with the possibility also to stay abroad up to 1 year and a half. And Professor Rebuzzi is the coordinator. And you can also take the double PhD with the University of Buenos Aires. Or you can decide, for example, to become a professional medical physics physicist in order to work in the hospital, for example, for instrumentation checks, treatment planning. And this is done after a 3 years school of specialization in medical physics. You can decide to work as a radiation protection expert. This is a professional certified to carry on tasks regarding the radiation safety compliance in the facility in which they use the radiation. And here in Pavia, we have the second level master program. And the 7th of June, there will be the presentation of this master in the Aula Volta of the university. After option, you can teach physics, mathematics in secondary and high school. You can work in companies, for example, for develop medical technologies, or you can offer freelance and consulting services. And this was my last slide. So if you want to know more, there is the website, and you can contact us anytime.